Good day, doctor. Today I'll be sharing my research on cadmium contamination in Malaysia agricultural soil, focusing especially on its environmental and health implications. Cadmium, CD, is a highly toxic heavy metal with an atomic number of 48. It's a growing concern in Malaysia's agriculture sections due to its accumulation in farming soils, mainly from industrial pollution, fertilizers, and e-waste. What made cadmium so dangerous? It is that it can be absorbed by crops, especially rice, that is the Malaysia staple food, and eventually enter our food chain, posing serious health risks to humans. Next, I'll proceed to case study part. One of the most concerning examples comes from Kinta Valley in Perak, a region historically used for tin mining. When the mining stopped, the land was reused for agriculture. However, cadmium residues from the mining era remains in the soil. Study reveals that the rice grown in this area contain cadmium levels exceeding the WHO and FAO safety limit of 0.4 mg per kg, with some samples reaching 0.6 to 0.8 mg per kg. So this result poses a serious risk to local communities, especially those who consume local grown rice on a daily basis. Next, part 3, how cadmium enter Malaysia soils. Cadmium contamination mostly comes from few pathways. The first one is phosphate-based fertilizer, commonly used in rice farming. These fertilizers often contain cadmium impurities. Second one is the industrial waste and e-waste disposal. In states like Selangor or Johor, the improper disposal of battery waste and electronic components release cadmium into soils and rivers. Third is the acidic soil conditions of the Malaysia tropical soils, which increase cadmium's mobility and uptake by crops, and then this part I will be explained later. And then the fourth is the flooded paddy field. This created an ideal condition for cadmium solubilizations and absorptions by the rice plant. So moving on to the next part, cadmium uptake by crops. Rice or Orza sativa is particularly vulnerable to cadmium contaminations. Its flooded growing conditions and deep root system allow cadmium in the soil to easily enter plants. Once inside, cadmium bioaccumulates, especially in the grains and the leaves, with very little being excreted. When humans consume cadmium-contaminated rice, the metal accumulates in soft tissues like the liver and kidneys, and it can stay in the body for up to 30 years. So, moving on to the part 5, chemical behavior of cadmiums. Now let's focus on the chemistry of cadmium, a key reason why it's so persistent and dangerous. Cadmium mainly exists in two inorganic forms. The first one is cadmium sulfide, CDS. This is an orange-yellow solid with very low water solubility. So it's under neutral or basic condition. CDS remains mostly immobile in soil. But in acidic or oxygen-rich environment, such as those found in Malaysian soils, CDS can oxidize, releasing CD2 plus ions, which are highly toxic and bioavailable. So the second one is cadmium chloride, CdCl2. Unlike CDS, CdCl2 is highly soluble in water. It can dissolve quickly and break into CD2 plus and Cl minus ion, which plants absorb easily, especially during the rainy seasons when the soil is waterlogged. This form of cadmium are influenced by two major environmental factors. The first one is the pH. The acidic soil increases cadmium solubility, and the second one is the redox potential. In waterlogged or oxidized soils, cadmium can become more mobile. This explains why cadmium contamination is such a serious risk in flooded rice field. It behaves differently depends on the environment, make it hard to control and also that it easy to absorb. So part 6 is environmental impacts. Cadmium does not just harm crops, it also degrades the entire ecosystem. First one, it disrupts beneficial soil microbes, which are essential for nutrient cycling. Second one, it reduces soil fertility, causing poor crop yields and also the plant stress like corrosive or stunted growth. Cadmium can leach into rivers, treating aquatic life and water quality. Last, it also weakens the soil's long-term productivities, affecting the food security in the contaminated regions. Moving on to the part 7, that's the health impact of cadmium to human. Cadmium is classified as Group 1 carcinogen by the International Agency of Research on Cancer, IARC. Long-term exposure is extremely harmful. The first is kidney damage. Cadmium accumulates in the kidneys, weakening their filtration system and also leading to chronic kidney disease (CKD). Second one is bone demineralizations. It interferes with calcium metabolism, causing bones to soften. This is the roots of infamous Itai disease, first documented in Japan due to cadmium poisoning. Third one is cancer. Long-term injections of inhalations has been linked to lung, prostate, and also pancreatic cancers. And health screening in contaminated areas of Malaysia have shown early signs of kidney dysfunctions and also high urinary cadmium levels among locals. So, part 8, the current situation in Malaysia. In Malaysia, cadmium levels in some agricultural soils now as high as 2.5 mg per kg, exceeding the Department of Environmental's limit of 1.0 mg per kg only. In Perak, 12% of the tested rice samples exceeded the Codex Alimentarius safety limit, while law like Environmental Quality Act 1974 and also the Scheduled Waste Regulation 2005 exit weak enforcement, limited tests, and also low public awareness have allowed the issue to persist. So next is the solution and mitigation part. Addressing cadmium contamination requires a multi-pronged strategy. The first one I think is by using the low cadmium fertilizer can also help in the contamination level in the soil. Next one is apply phytoremediation by using the plants to absorb cadmium from soil to remove the cadmium level from the soil, make the soil become clean and also last longer. Third one is conduct regular soil testing, especially in high-risk area. The fourth step is to launch a public educational campaign to raise the awareness among public or among the farmers. The last one is enforce stricter environmental laws and industrial waste controls to let the ecosystem and also the farming system better. Farmers must be educated about safer practice and consumers must be protected through better food safety monitoring. So the last part, conclusions. In conclusion, cadmium contamination is a hidden but growing threat to Malaysia's agriculture, health and environment. But it starts in the soil and then it enters the rice and silently accumulates in our bodies. But with early actions, scientific understanding and also public cooperation, we can reduce these threats and protect Malaysia's food security and public health for the long term. Thank you.